So in the second part of this lesson, I'm really going to tackle the exact same question. I'm still just going to be asking you to find the average value of a function. But this time I'm not going to give you the function itself. I'm not going to give you f of x equals. Instead, I can give you a graph, I can give you a table. There are a number of ways this question can be asked. So I'm just going to jump straight into an example, and we'll take a look at that. Okay, so some particle moves along the x-axis with a velocity at time t given by the graph below. Find the average velocity of the particle on the interval from 1 to 7. So I'm also introducing one other new thing here, and that is to say if they ask you to find the average velocity, it basically means find the average value of the velocity function. So because this is a graph of the velocity function, all I have to do is find the average value of this function, right? Now remember, from the previous lesson, in order to find the average value of this function, I just need to do 1 over 7 minus 1 times the integral from 1 to 7 of this function, which I'll call v of t dt. Right, so this is the t-axis, this is the v of t axis. And all I have to do is do this thing, right? The thing in front is easy. This is 1/6. The thing that you may be stumped about is how am I supposed to do this integral if I don't know what the velocity function is? And some of you may already be thinking in your heads like, oh, that's absolute value. I could probably write down what the function is. Sure, we could. Or we could recognize this thing just means what is the area under that curve. In other words, what is the area between 1 and 7 of this thing? And so in some sense, all I need to do is sort of split this thing up and figure these pieces out. In places that you can see symmetry, it's worthwhile to do that. For instance, here you'll notice that there's a triangle that's 2 by 2. So that means the area of that triangle is going to be 1/2 of 2 times 2, which is 2. So the integral of this portion here will be -2. You've got another section here that's exactly the same thing. This is a triangle that's 2 units wide, 2 units tall. So this one will have an integral of +2, which effectively means that these two areas will quote-unquote cancel one another out when computing this integral. So the only thing I really have to do is compute what this area is here, right? And I can sort of see that, well, there's a square here that has an area of 4. It's 2 by 2. And up here there's a triangle that has a base of 2 and a height of 1. So this thing up here has an area of 1. So overall, the integral of this entire thing, the total net area, is going to be 5. Now, if that took you by surprise, if you're not sure how I got that, I'd recommend you go back and look at that again. Remember that our previous lessons have always said when you're taking an integral, if any of that area ends up under the x-axis, that area effectively counts as a negative for the purposes of computing the integral. And like at this point, like yay, we're done with the problem. So it's 1/6 times 5. I get 5/6. That's the average velocity of the particle. We're done with the problem. So the point I really want to get across here is when they ask you for the average value of a function, you do need to use this. But that doesn't mean that you need to use a function notation thing like x squared minus 3x. You don't need, v of t equals something to take this integral. You can do it by, looking at a picture and finding the area under that curve. Or in the example I'm about to show you, what if I gave you a table of values? Could we approximate that from a table of values? So let's look at that next example. Okay, so this time a particle moves along the y-axis, and this time it's not, oops, I just realized I've got a little typo there. This should be a of t. Sorry about that. Moves along the y-axis with acceleration at time t given in the table below. I want us to approximate the average acceleration. In other words, I want us to find the average value of this function. So, as we figured out, finding the average value of a function means we do 1 over 12 minus 1 times the integral from 1 to 12 of this function a of t dt. So just like before, I don't have a function notation version of this function. I can't take the integral strictly speaking. But the problem does say, using a right sum, we can approximate the average acceleration. So in other words, I know I can't actually take the integral of a of t, but I could approximate it by doing a right sum using the information that I have here. So hopefully this will remind you of that process. What we're effectively doing here is we're looking at doing rectangles. And for each rectangle, I'm going to use the right side of the interval. So my first interval is from 1 to 5. That's 4 units wide. And I'm using the right side, so that would be 2 as the height. So 4 times 2 is the first rectangle. The second rectangle, this one is going from 5 to 7. From 5 to 7 is 2 units wide. And how tall is that rectangle? Well, from 5 to 7, I'm using the right side as the height, so that would be 5 for the height. And then the last rectangle, it goes from 7 to 12. That means it's 5 units wide. And its height is the right side, which is 1. If we add all of those things together, we end up with 8 from this, 10 from this, 5 from this. That ends up being 23. So in some sense, 23 is my approximation for what the integral is. So if I want the average acceleration, I need to do 1 over 11 times this approximated integral, which gives me that the average acceleration is 23 over 11. And that's it. We're done. I really want to emphasize, if you're asked to find the average value of a function, use this. Like, just use that formula. And then figure out some way to get the integral. Maybe it's a function and you take the integral. Maybe it's a graph and you count areas. Maybe it's a table and you use a right sum or a left sum or a midpoint rule or a trapezoid rule. Heck, maybe it's a problem where I just give you the value of the integral and all you have to do is multiply by the 1 over b minus a component. Understand these questions can be asked a lot of different ways, but all of them just come back to this formula. That's the end of this video. I think there's just one more in the sequence.